So in this lecture, we're going to talk some about how we interpret a standard electrical potential table. And any textbook or resource that you look at, it's going to have standard reduction potentials that are listed, of course, as reductions only, where this E naught value that's given in voltage um, is the potential that the atom or the molecule or the ion has to be reduced. Or the reduction potential. And if this is organized correctly, where we go from the most positive value 2.87, which corresponds to the reduction of diatomic fluorine gas, all the way down to the most negative value, negative 3.04, which corresponds to the reduction of lithium aqueous cation, then we can say something about the relative oxidizing and reducing powers of these analytes in electrochemical reactions. So the atom or the molecule with the highest affinity for electrons is the one that wants electrons the most or has the highest potential to be reduced. In other words, the highest reduction potential. And the sign matters. So the most positive reduction potential corresponds to the atom with the highest affinity for electrons.